Ecodesign Unit 3.3 Ecodesign Tools. Author, Environment Park. The unit includes LCA Methodologies, EPD, Environmental Product Declaration, Ecodesign for Sustainable Products, Regulation, ESPR. The European Commission defined ecodesign in Directive 2008 and 1998 as the systematic integration of environmental aspects into the product design to improve its environmental performance throughout the entire life cycle. LCA, the acronym for Life Cycle Assessment, can be a powerful tool to empower decision-makers to identify critical areas for improvement and apply better alternatives through eco-design. What is LCA? LCA is a systematic and comprehensive methodology used to assess the environmental impacts of a product, process, or service through its life cycle. An LCA considers the entire life cycle of a product, from raw material extraction, production, assembly, use, to the recycling or final disposal, and all transportation between these stages. This is known as a cradle-to-grave approach. The first definition of the LCA was done by the Society of Environmental Toxicology and Chemistry, SETAC, 1993. According to SETAC, LCA can be defined as a process to evaluate the environmental burdens associated with a product, process, or activity by identifying and quantifying energy and materials used and wastes released to the environment, to assess the impact of those energy and materials used and releases to the environment, and to identify and evaluate opportunities to effect environmental improvements. The assessment includes the entire life cycle of the product, process, or activity, encompassing extracting and processing raw materials, manufacturing, transportation, and distribution, use, reuse, maintenance, recycling, and final disposal. LCA is a standardized methodology based on ISO 12040, 2006, and ISO 14044, 2006. They are international standards that serve as the backbone for conducting an LCA study. ISO 12040-2006 lays out the principles and framework for LCA, providing a clear structure for carrying out an LCA study. On the other hand, ISO 14044-2006 goes a step further by specifying the requirements for LCA and offering guidelines to ensure the accuracy and reliability of the LCA results. Life Cycle Assessment, LCA, offers numerous benefits, especially for industries like fashion and textiles, where sustainability is increasingly critical. LCA allows to comply with regulations, with governments and organizations implementing stricter environmental regulations, particularly in Europe. LCA helps companies meet sustainability targets, guide companies to create more environmentally friendly products from the outset. This could mean designing garments that require less water or energy during production, using materials that are easier to recycle, or creating items that have a longer lifespan, reducing the need for frequent replacement. Identify waste management strategies, such as recycling or reuse, which can minimize the environmental impact of waste disposal. LCA supports actions of eco-labeling, marketing, and eco-declarations, EPD. The methodological framework of LCA, as outlined by these ISO standards, is divided into 4 interconnected phases. Goal and scope definition. This is the initial phase where the purpose of the LCA is defined and the scope is set. It involves identifying the product or service to be assessed, defining the system boundaries, and determining the functional unit, which is a measure of the function of the studied system and provides a reference to which the inputs and outputs can be related. Inventory analysis. This phase involves data collection and calculation procedures to quantify relevant inputs and outputs of a product system. Inputs concern the consumptions necessary for the product to succeed, such as raw materials and resources, water, energy, etc. Outputs: product, services, waste, emissions to air, water, soil, and other environmental aspects. Data are validated and put in relationship to the process units and functional unit. Impact assessment. This phase aims at evaluating the significance of potential environmental impacts using the result of the inventory analysis. It involves assigning inventory data to specific impact categories and modeling the impacts. Environmental impact categories are used to express the potential environmental effects. Depending on the goal and scope of your analysis, different categories might apply. The following are the most commonly used: climate change, global warming potential of greenhouse gases released to the environment; acidification, eutrophication, ecotoxicity. Each category is calculated based on all the emissions that contribute to that impact. For example, acidification is the indicator of the potential acidification of soils and water due to the release of gases such as nitrogen oxides and sulfur oxides. Interpretation. In the final step of the LCA, called interpretation of R, results is carried out to verify its reliability. In this step, the completeness, sensitivity, and consistency of data gathered and results obtained are done to guarantee their representativeness and suitability to be incorporated in created processes for datasets and impact assessment methods. LCA plays a critical role in helping textile brands identify and mitigate their environmental footprint. It supports the shift towards a circular economy, promoting strategies for longevity, recycling, and resource reutilization. IN. The following slides, an example of LCA analysis is textile as showed. In 2015, the brand Levi's released a LCA study, which expanded on their previous research to better understand the impact of cotton cultivation. The results of this study are helping Levi's and others in the apparel sector to take more effective and holistic approaches to reduce the environmental impact of all garment life cycles. Results of the study showed that cotton and consumer habits have a big impact on water and energy use. Fiber production, predominantly cotton, contributes by a wide margin to water consumption, while consumer care phase dominates the climate change impact area, driven by high use of non-renewable energy. Environmental Product Declaration, EPD, is a transparent and verified declaration containing quantitative information on a product's environmental impacts. The information declared within an EPD is calculated using the LCA methodology. EPD system is a true environmental product label that falls within Type 3 of the labels regulated by the ISO 14020 series of standards, in particular 14025. The EPD is therefore a standardized instrument based on the quantification of the environmental impacts associated with the product throughout its life cycle, calculated using the life cycle assessment methodology. The EPD report includes a summary of LCA results, environmental impact data, and other relevant information. EPD allows to define the complete environmental profile of a product service, exceed customer demands and specifications with increased transparency, identify possible improvement strategies, determining the most critical elements according to different categories of environmental impact, enable whole life cycle management, support innovative product development, such as improving efficiency for energy, materials, and transport costs. The European Union's Ecodesign for Sustainable Products Regulation, ESPR, which officially entered into force on 18 July 2024, represents a major advancement towards a more sustainable and circular economy. This new regulation broadens the reach of the Ecodesign Directive to encompass a wider array of products, including textiles and apparel, establishing uniform sustainability and circularity standards that align with the EU's Green Deal goals. As part of the shift, textile brands must conduct greater due diligence and align with ESPR compliance for textile standards covering the product life cycle. The ESPR aims to achieve several key objectives: decoupling, reduce the dependence of economic growth on natural resource use; supporting EU's goals, contribute to the EU's climate, environmental, and energy goals; reducing environmental impacts, minimize the environmental impacts of products; promoting sustainable consumption, boost the supply and demand for sustainable goods; standardizing ecodesign, establish consistent ecodesign requirements across the EU; reducing material dependencies. decrease reliance on critical materials, extending product lifespans, increase the durability, reusability, and repairability of products. The ESPR sets targeted sustainability and circularity requirements for all companies selling products in the EU market. These requirements will cover various aspects of product design and production, including durability, reusability, upgradability, and reparability, ensuring products are designed to last longer and can be easily repaired or reused. Substances, limiting the use of harmful substances that hinder circularity, energy and resource efficiency, promoting energy-efficient products that minimize resource consumption. Recycled content, increasing the use of recycled materials in product manufacturing, remanufacturing and recycling, facilitating the remanufacturing and recycling of products' carbon and environmental footprints, reducing the carbon footprint and overall environmental impact of products. Information requirements through a Digital Product Passport (DPP) aims to transform the textile industry by creating a detailed digital profile of a product's environmental impact and sustainability features. As an integral part of ESPR, the DPP is essential for promoting circularity, minimizing environmental impact, and aiding the rejuvenation of the European textile sector. The DPP acts as a digital fingerprint for textile products, offering comprehensive details about their origin, materials, and environmental impact. This knowledge is crucial for consumers to make informed decisions, for authorities to verify adherence to sustainability regulations, and for companies to identify and mitigate risks related to authenticity and environmental impact. The key features of the DPP are as follows: detailed specifications about the product, including brand, origin, and materials used, instructions for care, repair, reuse, and recycling, information regarding sustainable production practices, product lifespan, and opportunities for circular value practices, data about the product's environmental impact, including chemical compliance tools to aid consumers in making sustainable choices and to support authorities in compliance verification. Here you can find the references. Thank you for your attention.